As you may remember, the James Webb Space Telescope has new abilities that will be able to outstrip even the Hubble telescope. But what about teaming up? Two eyes to uncover all kinds of fantastic new phenomena. You definitely don't want to miss the James Webb Space Telescope and Hubble teaming up to peer through cosmic dust. Welcome back to Space Infinity, the ultimate team. Astronomers have been using the combined observations for both the James Webb and Hubble Space Telescopes to get the best possible idea of how interstellar dust can obscure the view of distant galaxies. The newly released image that has come along by using the combined might of the two telescopes has captured the appearance of two galaxies, seemingly very close to each other. It's incredible to think about how many stars and other celestial entities are in that area, with two whole galaxies as neighbors. But there's more to consider than just that. The image taken by combining the infrared measurements that were taken by the James Webb Telescope with the visible and ultraviolet light imaging done by the good old Hubble scope is showing all kinds of new information for scientists to consider when it comes to the behavior of galaxies as well as their arrangement. The two galaxies pictured in the image are known under one common name due to their relatively tight proximity. That name is VV191. And they appear to actually interact with each other. Of course, in space, distances can become exceptionally vast exceptionally quickly. And considering the size of the average galaxy, their proximity to one another is actually vastly distant. Light from the simple elliptical galaxy that is seen on the left of the image actually shines through the other complex spiral galaxy on the right, which is the closer of the two to Earth. As you know, spiral galaxies like our own Milky Way behave somewhat differently from the elliptical galaxies. But they make up the majority, roughly 72% of the galaxies our best and brightest have been able to observe. The other two types that we have observed can be categorized as elliptical and irregular. The light from the elliptical galaxy seen in the left of the image actually has to pass through the outer reaches of the spiral limbs of the other galaxy, which the James Webb Space Telescope has helped us to identify using its infrared abilities. Using the Webb telescope, we've been able to see the distinction between the different lights, with Webb capturing green, yellow and reddish hues, while Hubble's observations are what you can see as displays of different shades of blue. What does this mean? Roger Windhorse, an astronomer at Arizona State University, was the lead author of the new research paper on the discovery. His team obtained the data used in the image from early results of the prime extragalactic areas for reionizations and lensing science, or PEARLS, James Webb Space Telescope Guaranteed Time Observation, or GTO programs, GTO 1176 and 2738. The dust analysis was led by William Keel of the University of Alabama, while Ben Holderer of the University of Louisville in Kentucky led the Hubble data acquisition. The team leader Windhorse saw great potential in the image, as has been the way of things since James Webb was first activated and began operations. Windhorse had a lot to say about the new image. "We got more than we bargained for by combining data from NASA's James Webb Space Telescope and NASA's Hubble Space Telescope," Windhorse said. "Webb's new data allowed us to trace the light that was emitted by the bright white elliptical galaxy at left through the winding spiral galaxy at right, and identify the effects of interstellar dust in the spiral galaxy. This image of galaxy pair VV191 includes near-infrared light from Webb and ultraviolet and visible light from Hubble. It's fascinating. Looking more closely at the image, we can see that the light was emitted by the bright white elliptical galaxy on the left side through the spiral galaxy on the right. This is how the team were able to effectively identify the effects of interstellar dust inside the spiral galaxy. Webb's near-infrared data showed the galaxy's longer, very dusty spiral arms in much greater detail, making them look like they are overlapping with the central light source of the left side's elliptical galaxy, even though the pair do not interact." Windhorse continued, "VV191 is the latest addition to a small number of galaxies that help researchers like us directly compare the properties of galactic dust. This target was selected from nearly 2,000 superimposed galaxy pairs identified by Galaxy Zoo citizen science volunteers. Understanding where dust is present in galaxies is important, because dust changes the brightness and colors that appear in images of the galaxies. Dust grains are partially responsible for the formation of new stars and planets, so we are always seeking to identify their presence for further studies. To illustrate this point, take a look at the picture again. Just above the white elliptical galaxy on the left side, you will see a faint red arc that appears at the 10 o'clock position. This is a very distant galaxy that was also captured, and its appearance is warped, having its light bent by the gravity of the elliptical galaxy in the foreground. Its appearance is also duplicated, appearing as a dot on the opposite 4 o'clock position. These images of the lensed galaxy are extremely faint due to the proximity of the closer elliptical galaxy, and so they went unrecognized by Hubble. However, Webb's near-infrared imaging ability allowed us to see it. In fact, simulations of gravitationally lensed galaxies can help scientists to reconstruct just how much mass is in individual stars, as well as how much dark matter is at the core of this galaxy. New discoveries. If you take a closer look at the image, you can see that green, yellow, and red were colors assigned to Webb's near-infrared data, taken in 0.9, 1.5, and 3.56 microns, or F090W, F150W, and F356W respectively. Blue was assigned to two filters on Hubble, ultraviolet data that was taken in 0.34 microns and 0.61 microns, or F336W and F606W. It's quite a bonus to find yet another very distant galaxy through the combined power of Webb's near-infrared capabilities and observational power, as well as capturing the event of gravitational lensing. This is a brand new galaxy, which has not yet even been named, and it's a good representation of the pure power of the James Webb Space Telescope. In other recent images that have been received from the telescope, there have been celestial bodies that were unknown to scientists captured while looking at other things. Windhorse continued. Like many Webb images, this image of VV191 shows additional galaxies deeper and deeper in the background. Two patchy spirals to the upper left of the elliptical galaxy have similar apparent sizes, but show up in very different colors. One is likely very dusty and the other very far away. But we, or other astronomers, need to obtain data known as spectra to determine which is which. It is interesting to take in just how many sparks of light you can see in the image. Thanks to the combined power of the Hubble and the James Webb telescopes, we can see dozens, if not hundreds, of other bodies in the background of the image. This gives us a true idea of the scope of the universe. The twin galaxy VV191 was later selected to be a target for Webb's observations from about 2,000 galaxies that have been found in Webb's images by citizen scientists as part of a project known as Galaxy Zoo. This gargantuan project has seen over 250,000 people help astronomers to classify over 60 million galaxies so far. And the astronomers then used the Galaxy Zoo classifications to train an algorithm to recognize galaxy types. Thanks to this incredible new data that has been sent by the combined team of the Hubble Space Telescope and the James Webb Space Telescope, our understanding of how galaxies behave, form, and interact has been greatly expanded. We also know more about the mass of stars because of this phenomenon. The fact that every time Webb takes an image of a body in space, it ends up sending back far more information than scientists even knew they could obtain, gives us all a better idea of how many galaxies, stars, and of course worlds are out there. There are unfathomable reaches to space, and the James Webb and Hubble telescopes will continue to aid mankind in understanding how the universe came to be, how big it is, how many stars are out there, and thus increase the likelihood that there might even be life somewhere beyond the reach of human travel limitations. What do you think about this discovery? Be sure to subscribe to Space Infinity and check out our archives for all things space exploration. We will see you in the next one.